Here is a standard plot of strength versus density. We've seen that by using the appropriate slope, in this case 1.5, for different, whether it's a thin-walled material, a tie rod, or a beam, you can have different slopes over here, and then you can basically filter out options over here and select options over here from different families. The slope and the intercept for this line can move things up and down. And we've seen how a shaped steel can be competitive, and material substitution allows for constant strength for different shapes. And mainly, you have the shape factor introduced within the brackets under this 2/3 index over here. And so if you divide numerator and denominator by phi square, you can take the term within the power of 2/3. This is the same. So the new material property has a strength of sigma over phi square and a density of rho over phi square. And so this can be plotted as well. And in a manner that we talked about earlier, Z versus A can be plotted on a log-log basis, and you can create some options over there. So that is straightforward to do, to get these new material options using EduPack. Now, let us look at some of the things you can do. It turns out, just like you have a material family, which is broken up into different options, you can also go into options where you look at different structural elements. Okay, and so within that you will begin to see parameters such as the second moment of area I, the section modulus Z, the bending stiffness, which is proportional to E times I, and the bending strength, which is called YZ in the database, and a sigma Y times Z. And it can be done for, these can be done for not only a number of shapes, but number of materials that can be translated into the shapes. So if we use EduPack embedded, and these are the standard 7 options for prismatic shapes under the structural sections universe. And within that, you have these half a dozen family of structures. And within that, you have, for instance, in the I section, you have aluminum alloy, JFRP, and structural steel. And you have all these different attributes that are listed within that structural section. In order to get a feel for where is that data to be found in EduPack, if you go to browse and you click it, you will see that you have an option to look for structural sections. And within those structural sections, you can look at all these different options. And if you click on any one of these, right, you have almost 2,000 records from for level 3 among the almost 5,000 options that exist overall. And if you click on any one particular material, for instance, this tubular section, you will see that you have, under the general category, you have the price for range that these things exist in for this type of a geometry, the safety factor required, the recycle that exists, and the embodied energy. So now we are beginning to get into a new parameter, right, that can be used as a design criterion, which is how much energy is, in this particular case, for primary production, that is for creating that material. How much energy is consumed, and from a sustainability perspective, if that is to be factored into a design, doesn't matter what your political viewpoint is in terms of the Green Deal, but as a design engineer, you can satisfy design constraints provided by a customer based on sustainability metrics. Dimensions also, in this case, are provided, and there's ways to be able to specify those design constraints in a design. And then under section, you will have different options in terms of what is the section area limits based on these characteristics for that material. What is Imax? What is Zmax? And you can find Q and K as well for torsion-related loadings. And then you can plot those against mass per unit length, the bending stiffness, the bending strength, failure moment, and so on. This is an example for pultruded glass fiber reinforced plastic based on a vinyl ester matrix for a circular hollow of these given dimensions. Okay. And so try to explore that through the browse option.